Welcome back to Spanker Ranch Garage. Tonight's project, we're going to build a new tool for my milling machine. It's a 10-inch diameter, 1-inch plate of steel. It's an R8 collet with a stub in it and a carbide insert holder for a lathe. And with these three parts here and a couple bolts, we're hopefully going to build a huge flywheel type fly cutter. This piece is 22 pounds. So currently at the Spanker Ranch, I have like your standard fly cutters. This one fits in a collet. You'd use this for, fly cutting pretty small parts. This is a little bigger. I have cut like lawnmower cylinder heads with these, but this is really pushing it. You got a lot of stick out on the high-speed steel. Not a lot of inertia in this thing. It's pretty rough on, the Bridgeport as it's whacking around with like that. So the thoughts would be that we have this large flywheel type here. You've got 22 pounds of steel out here. This thing's really gonna carry some inertia with it. Take a lot of the, backlash slapping around that happens when you're using one of these. And this gives me the ability to cut like a 10-inch wide swath. So that'll cover pretty much any cylinder head, engine block, or other project that I need to work with. And then we'll be using this carbide insert holder, so that way I can put inserts in this. I don't have to be grinding high-speed steel. I can change different types of inserts, different radiuses for surface finish, that kind of thing. So this is going to be a little bit challenging for me because this is way too big to be playing with in my lathe, or at least I can't grab a hold of this thing from the outside. So I do need to finish both of these surfaces. They're extremely rough, just rough saw cut. And then also the OD of this thing looks like it's been sitting on a shelf for years. It's pretty nasty and a little bit banged up. So I want to get this looking nice and presentable. And we're going to bore it to fit the R8 spindle, weld this all together, and then finally install the cutting tool and figure all that out. I haven't really planned that out yet, but we'll make it happen. Our first challenge here is that my lathe will only turn a piece, or only hold a piece on the outside about 9 inches in diameter. We're at 10 1/4, just a hair under 10 1/4 on this guy. So we are going to start with this piece of pipe. I'm gonna weld this piece of pipe to the back face here, and we're going to chuck up this part by this piece of pipe, this sacrificial piece. And then facing this side here, and then we will bore our hole for our R8 collet. And then the plan is weld it together, move it over to the mill, and then put a tool in the vise, face the outside of it and face the bottom side of it. I think that's the easiest way for me to approach this, being that I have a very small lathe. Still have more sawtooth pattern here, so I want to take another cut. And then I'm gonna have to rotate my tool and finish off the rest of it, but that looks pretty nice. I mean, can't complain about surface finish. Pretty peachy for a 75-year-old hobby lathe from Sears. Not bad. I got a little witness mark here where I didn't match up perfectly, but taking a 10 1/4 inch piece of steel and turning it on this old lathe. Pretty funny. So I let this thing cool down, and then I realized there's a center in the bottom of that R8 stub. So I was able to turn it around, indicate it in, and get it back on the lathe. So I'm just gonna use this to clean up the welds I had to cut off for that tube I welded on. You can see here, there's still those welds on there. I gotta knock them off. I think I'll sneak in and take them off, but I'm gonna refrain from cutting this whole thing, just so when I do make that cut and this cut, it's done in the Bridgeport, and it absorbs any run out in that collet, any run out in my spindle. Kind of all just compensates for itself. So I'm gonna knock these welds off and then weld the outer side of this stub while it's on the lathe, and then we're moving to the bridge. And she cleaned up all right, but we still got some low spots, so let's go knock a couple more thousandths off. Beautiful. She wanted that heavy cut. It was starting to chatter and I just sent it. And man, that looks good. I've always said a Bridgeport is the best vertical lathe you can buy. All right, we're ready for the cutting tool. Damn, I actually feel bad getting fingerprints on this thing. So now we need to cut a notch in the side of this to hold an insert holder. And this actually doesn't, you don't want to cut the notch perfectly, I guess, at the radius here, right? You actually need to offset it by the thickness of the insert holder, which in this case is 1/2 inch. That way that this insert is cutting totally 90 degrees to the distance or the direction in which it's traveling, which is the tangent of, you know what I'm saying. I can't put it all into words because I'm too dumb, but it needs to be traveling. If the top of the plate is here, the tangential direction is this way, the tool needs to be traveling that way. So if you mounted the tool in the middle, as the tangential direction is this way, the tool will actually be dragging, or you know what I mean. So I found center on my disc here, and then I have stepped a 1/2 cutter diameter to the right. That means this side of the cutter is gonna be actually on the center of where it needs to be. So this is a 1/4 inch cutter. I stepped over 125. We'll go ahead and zero that. And then being that this is a 1/2 inch tool, I'm gonna take a full pass with the 1/4 inch cutter, step over a 1/4, full pass, and then any cleanup that needs to happen. So this is the thought. This will all be cut off the back. It won't be sitting here. It's just gonna be that insert bolted right in here, probably as short as possible to keep the stiffness up, and then little itty bitty insert holder. Wouldn't be a Spank Ranch Garage episode without a good test here to make sure this thing works. Of course, we're gonna hop right into something that's too big for this machine. This is a BMW inline 6 cylinder head. It measures like 27.5 inches from end to end, and it's 8 or 9 inches wide here in the center. It actually goes out to like 11 inches wide up front. So this cutter won't even take care of all of this, but I built this to handle more of the standard stuff, you know, LS heads, easy things like that. But anyway, let's dig her into some aluminum and see what happens. If it flies apart or it stays working, your guess is as good as mine. Pretty quiet. It is ringing a little bit, which surprises me. 8 thousandths off the top. You can see here we're low around cylinder 3. You can also see the back half of cylinder 3 and 4 are low here as well, but everything else cleaned up okay. I'm gonna take another 8 off of this and we'll see how our surface finish looks. But otherwise, this is going pretty well. Now, if this was a real like production job, I would swing the head over. That way this head could be centered on the table and I'm not hanging the whole thing off the side. I'd have it tied down by the spark plug holes. I'd have things done a lot differently here, but this is literally just to give a quick test on this new cutter and make sure it can cut a cylinder head with acceptable results. So far, this thing is sweet. This head turned out great. The surface finish is fantastic. You'll see some like marks, but you can't feel them. And the cool thing about the flywheel effect of this, one, you can tell the upper end of the Bridgeport is very happy with it compared to the old fly cutter that had no inertia. But two is like after a port with the normal fly cutter, any type of interruption, I used to get some chatter afterwards because the cutter would accelerate and decelerate. There's none of that. These edges are super crisp. Surface finish is fantastic. This is actually like too smooth for some gaskets on like American cars, but this would work good for the BMW stuff I do. You see discoloring here. These look like cuts, but you can't feel them. It's just, there was a chip in the way or whatever. But that is a very impressive job there. And the insert looks good. Everything's good with that. The interesting thing about this insert is this one has a very small radius on it, so I expected crappy surface finish. I have inserts with much more of a nose radius on them, which will give a much nicer surface finish. But I probably don't even need it. It's really turned out good. So I was running like 1.5 inches per minute on the feed with an 8/1000 depth of cut and 1,000 RPMs on the tool, which is very fast on the tool. I probably should slow that down a little. But either way, this turned out great. This will work for aluminum heads, and that is a successful recipe here. So, all right, very happy with that. That wraps up this episode of Spank Ranch Garage. This was something I always wanted to build even before I had a mill. I thought these flywheel style fly cutters were really a good idea. I think they're really easy on the milling machine. They give you a great surface finish, and they give you the ability to really flatten something pretty big, depending on how big you make this. This one weighs about 22 pounds. You could go a little more. You could probably make this 12-inch diameter if you wanted to, but it is a lot for a Bridgeport. They're really not made to be doing this kind of work. They do it well though. But the cool thing about making tools is I'm probably gonna have this for the rest of my life, and this tool will outlast me. Somebody will buy this at an auction someday when I'm dead and say, wow, that's nice to have, or that's built like crap, that guy sucks at welding, whatever. But that's not my problem. So anyway, this turned out awesome. Super happy to have it done. Like most things I build, you're gonna see it in future videos. It means we have jobs coming to utilize this kind of tooling. So happy to get that one done. Anyway, thanks for watching Spank Ranch Garage. If you got any questions on this, put them in the comments. I'd love to chat with you about it. See you next time.